Welcome to part 3 of my vSphere 6.7 professional course, where we'll start to focus on monitoring. And in the last section of this course, we learned about storage. So first off, let's learn about the free hands-on labs that we have from VMware that go well with this part of the course. And similar to the last two parts of this course, the ideal place to start is HOL 1910-01, Introduction to Management with vCenter Server. If you need to learn the basics of navigating vCenter, this is the ideal lab to start with. And when you've completed that, another lab that I recommend is HOL 1904-01. Now that being said, this lab is also very heavy on troubleshooting, which we're going to get to in part 8 of this course. So you may want to wait until part 8 to go ahead and complete this lab, but there definitely are some monitoring things like, for example, ESXtop and performance testing of applications that are going to be really valuable and go very well with part 3. And again, just a reminder, all these great labs are available free of charge, provided by VMware at hol.vmware.com. In this video, I'll explain the vSphere CPU scheduler and how it works to spread virtual machines across multiple physical processor cores. So let's start with some basic terminology. And these are key terms that I'm going to use throughout the remainder of this lesson. So first off, we have a world. A world is simply a thread of execution inside of an ESXi host. So a good example of a world would be a virtual CPU for a virtual machine. Each virtual CPU that I configure a virtual machine with is going to be a thread of execution on an ESXi host, and it's going to be represented in ESXtop as a world. So a virtual machine actually includes multiple worlds, especially if it has multiple processors. The number of worlds per VM is really going to depend on the number of processors, but there's also a world for displaying the mouse, keyboard, and screen. There's another world for the virtual machine monitor. So these are basically just processes that run for each virtual machine. And there's also worlds that are unrelated to virtual machines. So worlds for functions like vMotion, for example. So the worlds are basically just processes that my ESXi host is running. Then we have symmetric multiprocessor. So symmetric multiprocessor is a simple one. When you see SMP, what you basically want to think is this is what gives the ESXi host the ability to support virtual machines with multiple CPUs. That's really all it is. Symmetric multiprocessor, allowing a virtual machine to leverage multiple physical processors at once. CPU affinity, here's something I really don't recommend configuring unless you have a licensing requirement to do so. CPU affinity basically bonds a virtual machine to one specific physical processor. So that means that virtual machine can't be vMotioned. That virtual machine can't fail over with high availability. CPU affinity is basically forcing it to use one particular processor. So I try not to enable that feature unless I have a licensing requirement to do so. And then finally, ESXtop. That's something that we'll be taking a look at in future lessons. So I'm not going to get too deep on it now, but ESXtop is a command line performance monitoring tool that I can use to analyze the performance of an ESXi host. And many of the measurements and performance indicators that I'm about to talk about here can be easily viewed in ESXtop. So let's start with CPU sharing. Here we see a diagram of an ESXi host, and the ESXi host has two physical processors, two CPU sockets. And each of them is a quad-core CPU. So I have a total of 8 CPU cores. Now I go ahead and I create myself a virtual machine and I configure it with 2 virtual CPUs. Each of those virtual CPUs is going to be assigned to one of these processor cores.
So now I can see my VM is using two logical processors, using two CPU cores on this CPU socket. And if I boot up another VM on that same host, and this VM has 4 virtual CPUs, now that VM could potentially be sharing the same processor cores as the first virtual machine. So ESXi allows multiple virtual machines to share the same processor. It does so through a mechanism called time slots. What it basically does is allows these VMs to take turns with each other using that processor. So if I put too many VMs on the same host, they're not going to work quite as well. I don't want too many VMs sharing the same set of processors and pushing them too hard. So you should always be striving to hit that ratio just right. You want to make the most out of the processors you have. You want them to be 60, 70% utilized, but you don't want them to be 90% utilized and spiking up to 100%, because then your virtual machine performance is going to suffer. So that's our first key concept in this video. Virtual machines can share the same physical processor cores. So now that we've learned that a virtual machine can share physical processors with another virtual machine, here we see two VMs, each of them configured with 2 virtual CPUs, and they're sharing the same processor cores. Although in this scenario, it doesn't really make a lot of sense. Why have these 2 VMs sharing these 2 processor cores when there's other cores available with nothing using them? So the ESXi host will actually do CPU load balancing under the surface. We don't have to configure this. We don't have to manage this. It just happens. So in this case, the ESXi host may recognize the fact that it could be more efficient and take that second VM and migrate it to these other processor cores. Again, you don't even see this happening. It's all done underneath the surface, and the ESXi host will automatically migrate VMs from one core to another to improve performance. If you've configured CPU affinity, this is not possible. CPU affinity pegs your VM to one particular processor. Now let's take a moment to talk about hyperthreading. So here you see 2 processors. On the left, we have a non-hyperthreaded processor. On the right, we have a hyperthreaded processor. So let's think about what the difference is between these 2 processors. Now, what I want to start out by saying is neither processor is more powerful than the other. So both processors basically have the same horsepower. They're both equally fast. They're both equal. The non-hyperthreaded processor, however, is less efficient. So with a non-hyperthreaded processor, VMs are essentially needing to take turns. The VM on the left sends an instruction. It gets completed. Then and only then can the VM on the right send an instruction and have it get completed. So there's actually some idle time, right? And if we watch this animation, you can see where the idle time is. So here, VM1 sends a command to this processor. It's completed. Now the processor is doing nothing, waiting for that second command to come in. So there's that moment in between those CPU instructions arriving where the processor is idle. Let's look at it one more time. First command gets completed. Now the processor is idle. Second command arrives. Now the processor is idle again. So what hyperthreading does is basically reduce that idle time. It allows multiple virtual machines to send commands simultaneously, like we see in this animation. And now, the moment that the processor finishes with the first command, the first instruction, it can immediately move on to the second instruction because it's already there, ready to go. The idle time gets reduced. So hyperthreading doesn't necessarily make your processor faster. What it does is it reduces the idle time of your processor and makes it more efficient. And that's really what makes a hyperthreaded processor faster. Now, what do you need to know about this in your environment? Well, you need to have hyperthreading enabled on the BIOS. That's really the big thing. If it's enabled on the BIOS, then ESXi can take advantage of it and leverage it. So just make sure that if you have a hyper-threaded processor, that hyper-threading is enabled on the BIOS. Okay. So now we're going to walk through some examples showing how the ESXi host shares CPUs. And we're going to start with the old way. So we have to understand the way it used to work if we're going to understand the way it works now. And so we're going to do a little history lesson here. This is called strict co-scheduling. And so with strict co-scheduling, in this diagram, we have an ESXi host, and the ESXi host has 4 processor cores. Right? So that's what we're seeing here is an ESXi host with 4 processor cores. And so here at the bottom of the screen, we see we've got 1, 2, 3, 4. Those are my 4 processor cores. I have a single socket quad core CPU. So any VMs that run on this host are going to share these 4 processor cores. And so here I have 2 virtual machines running on this host. VM1, which has 4 virtual CPUs, and VM2, which has 2 virtual CPUs. So virtual machine 1 starts executing something. It needs its processors. What's going to happen is virtual machine 1 is going to grab those 4 processor cores and say, I'm using these. And so for that particular time slot, the purple VM, the VM on the right, is out of luck. If it wants to use processors, it has to wait until the next time slot. And my orange VM, it needs 4 processors in order to work, so it has to wait till the next time slot, till the purple VM is done. And so what you end up with is 2 VMs essentially taking turns. Now it's my turn to use the processor. Now it's my turn. You have to wait. Now it's my turn. You have to wait. They're taking turns. So what we end up with here is some wasted time slots. We see these slots that are shown as wasted slots. Those are CPU resources that could have potentially be used. But because the orange VM needs 4 processors in order to function, it can't take advantage of those spare 2 time slots. So what we can end up with in this scenario is something called a high CPU ready value. So what do I mean by CPU ready? CPU ready means this. My virtual machine is ready to execute something. So let's say that the purple VM has something that it wants to do, right? It's ready to execute some sort of task. It needs CPU resources to do it. But in this first time slot, all of those CPUs are currently utilized. This VM has entered the ready state, right? It says, I'm ready. I need physical processors. And the VM is going to remain in that state of being ready until those physical processors are actually available. Then it can actually carry out what it needs to. So the longer a VM remains in the ready state, the worse off we are. We want low CPU ready values because that means a virtual machine is ready to do something but hasn't done it yet. Okay, so now that we've talked about the way things used to work with strict co-scheduling, let's talk about the way things are now with relaxed co-scheduling. Again, I have a single socket quad core CPU, 4 processor cores, and again, I have the same 2 virtual machines. My orange VM with 4 CPUs, my purple VM with 2. And a similar situation occurs. The orange VM is using all of these cores in the first time slot. The purple VM has to wait. The purple VM may be ready, but it can't access any physical processor cores just yet. It has to wait until the next time slot. So far, it's really no different. Right? So far, it's really no different. Here's where the big change comes in. Now my orange VM can say, okay, the purple VM is using 2 time slots. I can take those other 2 time slots and use them. I can continue to make progress executing CPU tasks, executing CPU instructions, even though I can't get my full 4 virtual CPUs. And this pattern will continue. And so what we really have here is the big benefit of relaxed co-scheduling is the fact that we're not wasting those time slots. It's much more efficient. Right? But this introduces a different risk. This introduces a different problem called skew. So we can now run into a problem called processor skew or CPU skew. So when I configure a VM, like that orange VM, the orange VM had 4 CPUs. The operating system of that VM doesn't know what's going on in the background. The operating system doesn't know that those virtual CPUs are actually running on a physical CPU that's being shared across multiple systems. And so what my operating system expects is that when some sort of CPU instruction is kicked off, that all 4 of those processor cores will perform similarly. It expects those processes to be executed simultaneously. But if the ESXi host is not allowing it to use the time slots for vCPU 3, for vCPU 4, what's going to happen is those processors are going to start to get behind trying to execute those instructions. And if the difference becomes big enough, if a set of CPUs is making progress and another set of CPUs is not, this increases what we call skew, processor skew. And ESXi host has an acceptable threshold for this. So when that threshold is reached, the ESXi host will start holding back CPU 1 and CPU 2. They'll start limiting them. This is called co-stop. If you look in ESX top, this is expressed as co-stop. So if vCPU 1 and vCPU 2 are basically being throttled back, that's expressed as co-stop. So there's still problems. If you try and push too much work on these physical CPUs, there's still problems, even though we've kind of evolved since strict co-scheduling. There are still performance considerations that we need to think about here. Now, let's go back to our strict co-scheduling slide here for just a moment, because I want to talk about one other concept. I've mentioned you don't want to put too many VMs on the same host. You don't want to push too much work at one individual host because you're going to run into CPU ready. You're going to run into co-stop. You're going to run into these performance problems. There's another way that you can potentially relieve some of this contention. So let's say in this scenario, my orange VM is configured with 4 virtual CPUs. But let's say that my orange VM is currently using about 25% of the CPU resources that have been allocated to it, right? And maybe VM2, my purple VM, is using something closer to 70%. Well, I can solve all my problems right now with these 2 VMs because the VMs are improperly configured. They're not right-sized. VM1, my orange VM, it does not need 4 virtual CPUs. It doesn't need it. It's only using 25%. If I were to bring this VM down to 2 virtual CPUs, if I were to right-size it, now it wouldn't be using 25% of its resources anymore. It would be using 50%. Nothing wrong with that. Right? There's nothing wrong with 50% CPU utilization. So when I bring it back to 2 virtual CPUs, I'll see the CPU rise. For this VM, the CPU usage will rise to about 50%. That's going to have no performance impact on that VM. VM is going to work just as fast as it always did. As a matter of fact, that's actually going to improve the performance of my orange VM. And this is one of those weird concepts that people have a hard time wrapping their heads around. I can actually remove CPUs from the orange VM, and as I bring it down from 4 and bring it to 2 virtual CPUs, the performance will actually improve. And here's why. Now, VM1, when it needs to execute, it's going to try and grab 2 virtual CPUs. And when my purple VM tries to execute anything, it's going to grab 2 CPUs. These VMs don't need to take turns anymore. VM1 and VM2 each need 2 processors, and there's 2 processors open for them. They don't have to take turns. They can simultaneously use all of their processors at the same time, all the time. So by right sizing, I've actually reduced my CPU contention. And by reducing the CPU count of the orange VM, I've actually made it perform better. And I've made the second VM perform better as well. I've reduced the likelihood of CPU ready, and I've also reduced the likelihood of CPU skew. Because now it doesn't have a vCPU 3 and a vCPU 4. It didn't need them. vCPU 1 and vCPU 2 are having no problem getting the time slots they want. They're executing simultaneously. So I'm not going to see that co-stop either. So it's really beneficial to right size your virtual machines. If you're having CPU performance issues, that's usually step 1, right? Is to make sure that my VMs are properly sized, that they're configured with the right amount of CPU. Okay, so now that we understand the basic concept of how the vSphere CPU scheduler works, let's talk about CPU contention. So we can use shares, and we'll see more about that later in this course. But I can use shares to determine which virtual machine takes priority. If one virtual machine has twice as many shares as another VM, that virtual machine is going to get twice the CPU entitlement of that other VM. And that's really how this is all broken down. The hosts carve up those CPU resources into time slots, and then the share structure determines the entitlements. So how much CPU time is each virtual machine actually entitled to? That's determined by shares. CPU ready time occurs when a VM is ready to execute against the CPU, but must queue that command. That's CPU ready. My VM is ready. The processor is not. So the VM has to wait. So there's some great documents that you can utilize to learn more about CPU performance in vSphere. The first document I want to show you is the vSphere resource document for vSphere 6.5. And there's a similar document for vSphere 6.7 if you're on that release. So as you can see, this document's going to walk you through resource allocation, like shares and limits and reservations. It's also going to explain CPU virtualization basics. So some of the stuff that we talked about here is covered to a certain extent. And if we click on the CPU virtualization basics, it's going to walk you through, I said, some of the concepts that we just learned about, like software-based CPU virtualization and performance implications and so on and so forth, and how to administer CPU resources as well. So it's going to walk you through multi-core processors and hyper-threading, which we just learned about, how to enable hyper-threading as well, CPU affinity, and so on and so forth. So this is a good document for some of those topics that we've been covering here for CPU. And it eventually gets into things like configuring virtual graphics and managing resource pools and DRS clusters, performance at a higher level. It also explains NUMA architecture. So if you have NUMA architecture in your environment, this is a nice document to kind of understand the implications of that. Now here's the other document that I want to reference, and this one's an oldie but a goodie. The CPU scheduler went through significant enhancements in vSphere 5.1, and some of what you see in this document is going to look very familiar. It's going to walk you through the difference between strict versus relaxed co-scheduling, which we just went through, CPU load balancing, migrating VMs from one processor to another. It'll get into concepts like NUMA migration as well, and how NUMA impacts all of this too. So it's a really great document. It walks you through the different CPU states like wait and ready and all of those good things to know. It walks you through strict and relaxed co-scheduling and the differences between the two. So if you're looking for more details on any of those sorts of topics, I know it's an old document, but it's a good one. The CPU scheduler in vSphere 5.1 It is a great read to understand in depth what's going on under the surface with your CPUs. In this video, we'll take a look at a few of the different tools that are available for you to monitor your VMs, and we'll talk about some key performance indicators that you may want to be aware of. And in order to demonstrate these tasks, we're going to be using the VMware Hands-On Lab environment. These are available at hol.vmware.com. The lab that we're going to focus on in this particular lesson is the vSphere 6.7 Performance Diagnostics and Benchmarking Lab. So I'm not really going to follow the instructions of this particular lab. I'm going to kind of do my own thing. But this hands-on lab includes a lot of great virtual machines that you can use to generate workloads and get us some nice statistics to look at within these performance charts. So if you're looking to improve the performance of your vSphere environment, this is a great lab to take a look at. Now also, I'll note that the lab is for vSphere 6.7, but these lessons are applicable to either vSphere 6.5 or vSphere 6.7. And we're going to be using the vSphere web client. So here we are in the hands-on lab environment. I'm just going to do a few things to give myself a little more room to work with. I'm going to make my browser full screen. And I'm going to unpin all of these little panes that I don't need to look at right now. So I'm just going to unpin them. And now I've got lots of room to work with. And I'm going to start by going to hosts and clusters. So here you can see in the hosts and clusters view, I've got all these virtual machines powered on, all these perf worker VMs. And so let's start by focusing on one of these virtual machines. I'm just going to pick perf worker 02A. And anytime we're talking about monitoring VMs, what we want to do is click on the VM and go to the monitor tab. And under the monitor tab, there's a variety of information available. So here I could see if there was any alarms that were currently triggered. I can also see all of the alarm definitions for this particular VM. So if we click on triggered alarms, it's going to show me I don't have any alarms triggered right now. Alarm definitions, these are all of the alarms that can possibly get triggered by conditions on this virtual machine or by events on this virtual machine. So we got a bunch of alarms defined there. But what I really want to focus on are the performance charts that are available in the vSphere web client. So if I click on performance here, I can take a look at overview and advanced charts. So let's start with the overview charts. And the overview charts are exactly what they sound like. They're a great way to get an overview, performance-wise, of what's happening with this particular virtual machine. So if I'm not really sure what the issue might be, if I'm just experiencing slowness on a VM, the overview charts are a great place to kind of begin my troubleshooting process because there's a whole bunch of information here on CPU percentage, on memory usage, on CPU usage that could potentially point me in the right direction. If I'm not really sure what the issue is with this VM, maybe it'll become apparent as I'm looking at these overview charts and just getting a good overall idea of how this VM is performing. And so you may notice I'm clicking on these charts. Each chart, you have to click on it to populate the data. And there's not a whole lot of great data here pointing me in the exact right direction. So at that point, I may move on and look at some of these advanced performance charts. Now, the advanced performance charts are more complex for sure. They're more complicated to utilize. And you really have to have a decent idea of what area of performance you want to focus on before you get into the advanced charts. So for example, I may want to look at some memory or CPU as a particular area of concern with this virtual machine. So let's go back to perf worker 02A and let's look at some of the advanced performance charts here. And what I'm going to do is I'm going to start with a real-time chart. So let's go to chart options here. When you look at a real-time chart for a virtual machine or for anything in the vSphere web client, those real-time charts are updated every 20 seconds. Now, if I want to look at a longer time interval, I can. But I'm going to simply look at a real-time chart. And so I'm going to choose a memory performance chart, again, real-time, so it'll update every 20 seconds. And I want to take a look at a few key metrics here. So I'm going to deselect active memory. I want to look at ballooned memory because I want to get an idea of if any ballooning activity is happening on this particular VM. And then I can look at other charts like consumed or granted memory. I can look at entitlements to see how much memory this virtual machine is being granted at the moment. I can see if swapping activity is occurring as well. So that would be bad. If I see swapping activity occurring, I know that we have a serious memory contention issue. And so I'm just going to go ahead and hit OK here and take a look at this performance chart that I've just designed for this particular VM. And it's going to display all this information real time. So you'll see the chart kind of moving over towards the left as new information populates. So for example, I can click on ballooned memory. I can see there hasn't been any ballooning activity. I can click on memory entitlement. I can see at any given moment, this number can change. It depends on the share structure and how much memory is in use. So my entitlement can potentially change depending on what's going on the host at any given moment. And at the moment, I have no swapping activity, so that's good. If you see ballooning activity, that means the host is attempting to reclaim memory. Swap in and out, that means the host is really starving for memory. So that's a basic real-time memory chart for a virtual machine. Let's take a look at another real-time chart. Let's take a look at CPU this time. And I'm just going to go ahead and pick the first processor of this virtual machine. And I want to look at two things. Number one, I want to look at co-stop. Basically, what co-stop is going to tell me is, are my processors getting out of skew? Now, that's definitely not going to be the case here because I only have one processor. But I like to highlight that metric. And the other metric that we're going to take a look at is really our most important one, CPU ready. So actually, I'm going to deselect co-stop because we can only select two values here. And if you click on this little information icon, it's going to tell you, yep, you can only select two distinct units at a time. So we'll look at CPU ready and we'll look at CPU usage as a percentage. And let's go ahead and hit OK here and see what our performance chart looks like. Okay, so now we can see our CPU ready chart. You can see that CPU ready was pretty high when the virtual machine initially booted. That was when I booted the VM. So why was CPU ready value high when I booted this VM? Well, VMs use a lot of resources as they boot. And so remember what ready values mean. When your virtual machine is ready to execute some instruction against the processor, it enters the ready state. The moment that those instructions get executed by the processor, the VM leaves the ready state. So a lot of time, a lot of higher ready values, those are typically bad because it means that the VM is ready to do something, but it's waiting on physical processors. And we can see here our latest CPU ready value is 39. And if we scroll over a little bit to the right here, we can see our average CPU ready is kind of skewed because of the boot, but it's at 118. So let's focus on this CPU ready value right here. So let's just go with 30. Let's assume that our CPU ready is staying somewhere around 30 milliseconds. What does that mean to us? Is that a good value? Is that a bad value? It's hard to say without doing a little bit of math here. So my latest CPU ready value is around 30. So 30 milliseconds of CPU ready over the last 20 seconds. So that means out of 20 seconds, we have 30 milliseconds of latency. That sounds pretty good. I don't think we're going to have a big problem there. But just to make sure, I'll bring up my handy little calculator here. And we'll say, okay, about 30 milliseconds. So we'll put in 30 over 20,000 milliseconds, right? Because we had 20 seconds. So that's 20,000 milliseconds. So we can see here less than 1% of the time. Less than 1% of the time, our virtual machine is in the CPU ready state. That's not bad at all. That's a great number. So it depends on what chart you're looking at. If you're looking at the past day, the sampling interval will be shown right here. If you're looking at the past week or past month, the sampling interval will be shown right here. So you have to take those CPU ready values that are being expressed and think, okay, if I have this many milliseconds over this sampling interval, what does that mean? What's my percentage of CPU ready? And you want to see something below 5%. That's your guideline. You want CPU ready values to be less than 5%. Now here I can see my average CPU usage, and the average CPU usage is around 1.6%. If this virtual machine had multiple virtual CPUs, I would now go remove some of them. This virtual machine is barely using the CPU that it has, but it only has one CPU, so there's not much to do there. I'll just leave it alone. So those are some of your good performance charts for virtual machines, and you can look at other ones like data store and disk. Right? So if we click on disk, you can see latency information here. Typically, what you want to see is something around 10 to 12 milliseconds of latency or less, though that's a fairly average number for storage latency. If you have like an all-flash storage array or something like that, you're probably expecting to see better numbers than that. So with storage, really read and write latency, those are kind of the two big ones that you typically want to focus on from a storage performance perspective. How long are storage commands taking to be completed? Are they happening really quickly? Are they happening really slowly? We can see the average latency for this VM is 0.11 milliseconds for writes and 0.02 for reads. This is extremely low latency. So normally you'd probably see something up around 6, 7, 8, 9, 10 milliseconds or so. Again, though, it really depends on the speed of your storage array. If it's something really fast, if it's all flash, it's going to be much lower than 10 milliseconds. And then finally, the last performance chart that I want to take a quick look at for this VM is the network performance chart. So again, I'm going to go to my advanced performance charts, and under network, there's a couple of key metrics that I want to take a look at. What I want to look at is received packets dropped and transmit packets dropped. And if you are seeing any values here, if you're seeing dropped receive or dropped transmit packets, that's usually a really strong indication that there's some sort of congestion in your network. So that's what I want to think when I see those numbers that are higher than 0, is I've got some kind of congestion going on in my network that I need to address. Now finally, one more thing I want to look at from a monitoring perspective. We can go to tasks and events. Here we can see basically what's been going on with this virtual machine. You can see that I powered it on. You can see some reconfigurations that have been done. And so you can kind of get an idea under tasks what we've been doing from an administrative perspective and who has been doing those things. Those are our tasks. And our events are basically anything that's happened to this VM. So has it had alarms go off, for example? Here's an alarm that changed to green status. Has it been powered on? Basically, the events are going to show you everything that's happened. Under schedule tasks, you can actually schedule certain things like a reboot of this virtual machine or a vMotion of this virtual machine. You can schedule all sorts of tasks here, a clone of it, changes to the resource settings that you want to have these occur at a certain time of day. You can schedule those things here. And you can also monitor compliance with a storage policy. So if you have assigned a storage policy to this virtual machine to control where its virtual disks are stored, what kind of data store they should be on, If I've configured those storage policies, I can monitor that here to see if the virtual machine is currently in compliance with whatever storage policy has been assigned to it. In this video, I'll introduce you to ESXtop and how it can be used to monitor performance. And in the next video, I'll give you a full demonstration of how to use ESXtop. But for the moment, I just want to give you a couple quick resources that can help you learn your way around ESXtop more easily. So here you can see I've gone to Google and I've simply typed in ESXtop reference running dash system. This is an easy way to find this great document that I frequently reference when I'm trying to figure out what I'm looking at in ESXtop. And it's the vSphere 6 ESXtop quick overview for troubleshooting. So, what's so great about this document? Well, number one, it's going to break down everything for you very simply. Right? It's going to start with an overview of all of the ESXtop commands, which is a great way to start to get to know, what happens when I hit M, what happens when I hit a capital V. Like I said, I'll demonstrate some of this stuff for you in the next video, but this is a great reference to just have handy. And when you launch ESXtop, it'll bring you to the CPU screen. So here you can see a nice summary of all of the fields that are being shown for you on the CPU screen and a quick summary of what each of those fields mean. Like, for example, CPU ready. The percentage of time a VM was waiting to be scheduled. The VM is ready. The physical processor is not. If you see values above 5%, take care. That means you've got a bit of a problem on your hands. And so all of these little fields in ESXtop are broken down for you very clearly here. Here's the disk and the NUMA and the memory fields in ESXtop. And if I scroll up a little bit, you'll see network. Things like drop received and drop transmits that I need to be concerned with. And there's even an area of ESXtop for vSAN now. You can see recovery operations that are occurring and all sorts of great information like that. So this is a great reference if you're just getting started with ESXtop, or even if you're like me and you've been using it for a while. It's a very handy, quick one-page reference to help you navigate your way around ESXtop. The next document I'd like to show you is the vSphere 6.7 Performance and Monitoring document. There's also a version of this for 6.5 as well, but here you can see all different ways that we can monitor the health status of a host, the guest operating system of a virtual machine, vSphere Health, how to look at events, alarms, and automated actions, and all sorts of other great information, including information on ESXtop and how to utilize ESXtop. And one of the things you'll find in this document is how to actually run ESXtop in batch mode. So if you want to capture the output of ESXtop over a period of time, you can actually run it in batch mode and capture ESXtop output. So this is a great way to get all sorts of details about the CPU panel and the memory panel and all the different panels and exactly what the indicators in them mean. In this video, I'll demonstrate how to use ESXtop to monitor an ESXi host. So in this video, I'm again using the hands-on lab environment at hol.vmware.com. And you can see here, this particular lab is equipped with PuTTY. And so we've got PuTTY here available to us, and we can launch PuTTY, and we can connect to our ESXi hosts. So let me go ahead and close this and start this over. Here's PuTTY down here at the bottom of the screen. I'm just going to click it. And what I'm trying to do is get command line access to an individual ESXi host. That's what ESXtop is all about. I'm going to get into one particular ESXi host, and I'm going to use ESXtop to monitor that host. So I'm going to load up this session here. And I'm actually going to make a quick change before I get in there. I'm just going to increase the size of my font to make it a little bit easier for everybody to see. And then I'll go ahead and connect to my ESXi host. Now, what you can also do is you could locally connect to an ESXi host and use the shell. to launch ESX Top, but I'm going to do it remotely. So I am using PuTTY to establish an SSH session. And then on the ESXi host, I'll simply just type ESX Top and hit enter. And what it'll do is it'll start me at the CPU screen. So here I can see my physical CPU information up at the top. I've got 7 VMs configured with 7 virtual CPUs, and I can see my average load on the physical processors of this ESXi host. Here's my physical CPU used percentage, and here's my physical CPU utilization percentage for this particular ESXi host. And my CPU utilization is relatively low. It's averaging around 47%. And here are all of the different worlds and groups running on this ESXi host. So a group is simply a collection of processes, right? Here we see GID, those are group IDs. And then I can see the number of worlds. That's the NWLD. So how many worlds are in this group? How many threads of execution are associated with this particular group? That's the number of worlds. And we've got all kinds of processes running here that are internal to this ESXi host. So what I'm going to do is I'm just going to type a capital V. And look what it does. It removes all of those other processes and just shows me my virtual machines. So up at the top, I've got memhog. Memhog has 7 worlds. And then I've got all my perf worker VMs. They have 9 worlds each. The number of worlds depends on how many virtual CPUs the VM has. So I've got 7 for memhog. I've also got other worlds, not just the virtual CPUs, like the monitor, keyboard, and screen. So it's basically all of the processes that make up a virtual machine. The virtual machine monitor is one of those worlds. So what I really want to focus on here on the CPU ESX Top is what is going on from a CPU ready percentage. Here you can see this percent ready column here towards the right, and percent ready is below 1% for every VM. That means I'm not really running into CPU contention on this host. So it's very easy to monitor CPU ready here. I don't need to do any math. I don't need my calculator. I can simply see ready presented as a percentage. And if it's below 5%, I'm not really worried. On the far right, I can see co-stop. Again, most of these VMs are single processor VMs, so I would expect co-stop to be 0. But if I have CPU skew, if I have one processor that's making progress faster than another, I'll see some values here with co-stop. Let's take a look at the memory output for ESX Top. So I'm just going to hit M, and that'll bring me to the memory screen. And then again, I'm going to hit a capital V so that I just see my virtual machines. And now I can see all sorts of good information about my VMs. So let's start with memhog. I can see the memory size. How much memory has this VM been configured for? How much memory is it actually being granted? And I can see, is there any swapping activity, swapping current and swapping target? How much swapping activity is currently occurring on this VM? And if I see a swap target that's higher, that means that swapping is increasing, but currently it's 0. And you can hit F here to change the fields that are displayed. So if I hit F, maybe I want to see certain information and there's certain information that I don't want to see. So I don't really care about swap anymore. So I'm going to hit K to get rid of that. I'm going to hit L to get rid of swap. I'm going to hit O to get rid of memory overhead. And what I really want to see is statistics related to ballooning. So I want MCTL. The process that runs ballooning in your virtual machines is called the VM memctl driver. And so I want to look at MCTL. Those are the statistics that I'm really concerned with here, is ballooning activity happening on these virtual machines. And so let's take a look at what we see. MCTL question mark. That's basically asking, is ballooning enabled or disabled? If you have VMware tools installed on your virtual machine, you're probably going to see a yes here. If VMware tools is not running on your virtual machine, you'll see a no. So the balloon driver is baked right into VMware tools. And you want that balloon driver running. That's how the ESXi host reclaims memory that's no longer being used. So ideally, all of our VMs should say yes here, unless there's a really good reason to not have VMware tools on those virtual machines. And the MCTL size, that's current ballooning activity. The MCTL target, that's how much ballooning activity is going to be happening in the future. So if the target is higher than the MCTL size, you know that ballooning activity is increasing. Let's hit D and go to disk. And here you can see all of the storage adapters for this ESXi host. So I've got VMHBA0, VMHBA1, VMHBA64 and 65. These are the physical storage adapters for the host itself. And what we can see here, some critical performance indicators. What is the device average latency? That means what is the latency of the storage system itself? It could be iSCSI, could be Fiber Channel, could be whatever. How much latency are we seeing from that? Versus kernel latency, how much latency is the ESXi host itself introducing? And the kernel latency should always be below 1 millisecond. The device average latency, you may see that like 8 or 9 milliseconds, and that's pretty normal. Kernel average latency should be really low, below 1 millisecond. And if you combine those both together, you get your guest average latency, which is the total latency being experienced by your virtual machines. If I hit S, I can change the delay. So remember when I said we had real-time performance charts inside of your vSphere web client? Well, I can change the seconds to delay here. So I could hit 5. That's going to change how frequently this display is actually refreshed. I can put in 2. And now my display is actually going to refresh every 2 seconds. So you can actually modify those different values here. I can hit H and go for my help. So now I can see, add or remove fields or set the delay in seconds. Some of the things that you've seen me do. I can also switch my display. So far we've looked at CPU, memory, and disk adapter. Let's take a moment and go to disk VM, which is a lowercase v. And here we can see each of the individual virtual machines, how many reads and writes per second they're creating, and what is their latency for reads and writes. So as you can see, ESXtop is very powerful. I'm just going to hit N as I talk here. ESXtop is very powerful because it's giving you a whole lot of information in one place. You can see here, I'm seeing network activity for all of my virtual machines, all of my VM kernel ports, and all of my physical adapters on this particular ESXi host. Right? So the VM NICs, those are my physical adapters. I can see my VM kernel ports, and I can see which physical adapter they're using. I can see my virtual machines down at the bottom and what physical adapter they're using. And I can see packets transmitted, megabytes transmitted, packets received. I can change these fields and just simply focus on dropped receive and dropped transmits if that's what I'm concerned about. So I'm just going to unselect a bunch of these counters so that I can see those dropped received and dropped transmits. And I have 0 drop received and 0 drop transmits. So I'm in pretty good shape. So that's a quick summary of ESXtop and how it can be used to speed up your troubleshooting process, and how you can see a whole lot of information and a whole lot of metrics very quickly by using ESXtop to analyze the performance of an ESXi host.